Hey, so here's my high voltage producer thing I built. As you can see, it closely resembles a DVD player, which is, well, it's because it used to be a DVD player, an old one. My mom and dad got me for the lasers. They found it and they just gave it to me. So, anyways, I was going to make an engraver as the next project. So, anyways, of course, it has a 110 input, 110 AC input, and on the exterior you have these two high voltage leads. And then you have a nice fan, 12 volt DC fan. Now inside we will find we got all sorts of goodies in here. I'll move the light. Now over here you have your DVD player power converter circuitry, which outputs wonderful, like extremely accurate 5 volts. It's like it goes between 9.9 and 5.02. I mean, extremely consistent. So you have a really good 12 volt output, 5 volt, and 3.5 volt output. So I was considering using it for some other circuitry because it's just pretty nice. And you can see you have the 12 volts running to your fan, and then I took 3.5 volts and I ran it to the bug zapper circuitry right there. I'll just use my hand right there, and that circuitry might be a little better. That circuitry came from a bug zapper, and anyways, basically you can produce high voltages from it. However, you can burn it out pretty easily if you run it very long, because they're typically just used for quick sparks, one bug or so every minute. I don't know. I don't know the rate. Anyways, so I upgraded the transistor to I got the transistor from some other thing. I got a tube TV because, as you can see here, I have a flyback transformer. So I think I got the transistor out of that or something, but it can handle up to 10 amps, and the old transistor could handle up to 6 amps. Surprisingly, it was a tiny little thing. It actually exploded on me at one point because I think I was pumping the circuitry with 5 volts and ran it for too long or something. Anyways, it exploded. So I got this other one, which should be able to do better. I haven't done any of the math or anything to figure that out, if it will or not. Don't want to spend the time to do that. So, yeah. Then you also have your spark gap, which, of course, is your switch to induce a high surge of current through the coil. And then, of course, then your output of your coil is right here, which actually, it's two flyback transformer cables, as you can see. One of them, I blew the other one because I hooked up to a fluorescent bulb circuitry, and man, it was amazing. 1.5 to 2 inch sparks, but at that, I don't know what happened, but it fried the transformer, I think, and also the circuitry. Yeah, so I've just found the leads, stuck it on there, whatnot, So that's where your high voltage comes from. I do not know what this is outputting as far as voltage wise. I don't want to try to measure it with my multimeter. Anyways, so that's about it for the insides. Let's go ahead and check out how it does. I'm gonna if I can put this back on my head. Okay. Alrighty, this goes back on here. Yada yada yada. I'll just kind of flop it on there. Not very well, but here we go. As you can see here, I have an LED light that was off the bug zapper. I just put it right here. The fan's going. You can hear that clicking, which is the spark gap inside. Now, without electrocuting myself, I will try to show you the... there we go. It's a pretty solid, pretty steady. It just stopped. Okay, we're back. Pretty steady current, but you know, it might have stopped. There's certain issues with this circuitry. I don't know. I'm trying to debug them, but anyways, yeah, it does. It does like a ½ an inch, I guess, spark. 3/4 maybe. Yeah. So then after this, I'm gonna hook this up to a Tesla coil. So I know Tesla coils, you typically want like a consistent, like pretty frequent current, but this is the best I can do for now. I'm sure there's a lot I can improve on this circuitry, but I'm not gonna be able to do it. I just have too many other things to do. So yeah, this is my high voltage producer box transformer thing.